and that is a pleasure for us. JBP has been in Malaysia since 2008, and the idea of our company was to bring knowledge, know-how, and technology, mainly from Europe, into Malaysia. As Frank mentioned, we have been in the industry for many years, and there's always two sides of the coin. To be for good, but also maybe you get a bit too square minded if you don't get new influence. But as my policy has always been, with help I can do everything by myself, and that is how I have survived over the years. Here in Malaysia, we have been, as I mentioned, for quite some time, and we have, beside that, been working in many countries around the world. Actually started back in Japan in the early 90s with little experience, but year by year that has also grown. I'm Swedish by birth, live in Spain, have a main office in Germany and half of the family in the UK. Now we never know what's happened with the Brexit and so on, but that is another side of the story. So we are actually getting information also to teach as much as our participants at the courses. Important is to exchange experience. In different countries you have different conditions and need different kind of adoption of the technology to be used. So I'm pleased to have so many experts around here. If you look at the region where we have been active, it started back in Singapore, went over to Malaysia, and also we have done work in Vietnam and Indonesia. The group, it's a small group which consists of 4 companies. So we started back in 2004, and in 2008 we established a first company in Malaysia, followed by consultancy service and a contracting company back in 2013. If you look at the sewer network in this country, we have about 20,000 kilometers. 20,000 kilometers. We have roughly about 20% in a critical state. So that is something you have much bigger knowledge than we have, and therefore I will just highlight this one. I would like to hand over this to my colleagues, but before I go further, I would like to give IWCAN a big thank you for all the support you have done for us to be able to be here. Frank, for all the work you have done together with people here to organize this course. As I said, with help, I can do everything by myself. Last but not least, my old good friend, Dr. Deb Doney, which will kick off this course. Dec is a legend in this industry. He has many years of experience. I will not tell how many, because I don't know if I tell this kind of big figures. But he is a legend in our industry, and we are very pleased and happy to have Dec here to support ourselves and, of course, yourself. Like Frank said, the course here will be a wide, broad course in trenchless technology, but I have to say that we have one of the biggest experts here today and tomorrow. So, with that, I would like to say thank you so much for showing up this morning, and I'm really looking forward to these 2 days to come. And I leave over the stage to Dec.
Excuse us a moment.
Once again, good morning. It's very nice to stand here in front of you. I don't plan on standing much of the day, but I am going to be up here much of the day, so you might see me sort of slipping back on the desk and relaxing, because people of my age usually take a nap about 10 o'clock. We have 3 sessions today, sort of session on current methods and technologies. Later this morning, this afternoon, we'll talk about the benefits and limitations of trenchless technologies. And finally then talk about a little bit about selection and a lot more about the design of lining systems. And at the end of that, I've got a spreadsheet that I'll put on the screen to show you an easy way of doing the design work. And you could decide what parameters you'd like to put in. Change them around. It's just a matter of sticking the data in, and it'll come up with a line of fitness. You get a feel for how easy it is to operate and what simple process it really is. So I'd like to begin really by first of all working out how to use this. This isn't working. There'll be a reason why it isn't working.
Forward back.
Is it turned on?
Sorry.
Right. So that's my basic lesson. We pointed out for it.
Should just that computer. No, it doesn't have to.
Doesn't matter at all.
Sorry.
I think I'll leave.
I must have the magic touch. Just one quick touch.
I think I'll be too far.
Try again. Sorry.
I think it's the cactus plant.
Try that. You see if it goes.
Okay. Great start to the day. I want to talk a bit about sewer construction, which sort of started a long, long time ago and gradually shifted into Europe. So it's just a bit of interesting background. Give you a feeling of where pipeline construction has come from and how it's worked. So we'll have a quick look at how historic materials have been developed, where they were developed, how the networks grew. We'll then talk about the standards that operated at the time that these pipes were first installed. A little bit about the problems which everybody knows about, that if you don't fix your pipes, if you don't maintain your pipes, they're not going to function, and you're going to have problems quite soon. In fact, serious problems. And then we can look at how assessments have been made and how that's driven expenditure in various countries. Take us into the 1980s and the beginnings of the trenchless technology era. As we've been at it now for 30 odd years, I think we can reliably call it an era. It's not just a question of time. So it did work. So in the up until about the 19th century, we've had we've got In the 19th century, we had major cities of Europe, North America, and indeed India. And they had culverts which took stormwater to rivers, and the water was taken care of in that way. We had solid waste being separated and carted off and used as an agricultural fertilizer. And that was a viable business when cities were relatively small. But as cities grew bigger and bigger, it became impossible in a day to truck solid waste out into the countryside and use it reliably. And so cities were in danger of being overwhelmed by their own sewage. And I'll tell you a little anecdote about how Tokyo was totally overwhelmed by the sewage when we get to that point in the presentation. We have mainly very traditional materials. Bricks have been made since about 4000 BC. We've had clay pipe being made since 2000 years ago, of various kinds. And then we got into a well-documented problem in London, where the Prime Minister was Disraeli closed Parliament down because people were choking on the smell coming off the Thames. So a lovely place to be. Holidays in London in the 1850s were not that popular. So we have clay pipes and clay brick from, as I say, 4,000 years ago. We have masonry brick sewers constructed in Rome and in any other city that the Roman conquesting armies took over. So London had sewers in about 100 AD because the Roman army got there, built a little city. They built it where the Thames was narrow enough to throw a bridge over the Thames, and the river was big enough for ships to come up from the North Sea into what became the capital. In those days it was just a Roman place, not a significant place at all. But it became significant because it had clean water and dirty water processing really quite early in its history. And then not a lot happened for quite a long time until the 18th century. There were stoneware pipe sewers put in a lot of cities around the Mediterranean. Paris in the 16th century put in stone sewers lined with stone, with cut stones. And some of them are still functioning today. We have the massive sewer which runs into the Tiber in Rome, and that's been functioning as part of the public system for over 2,000 years. It still is. But we didn't see any major change in things until the invention of a machine to manufacture clay pipe in about the 1830s. The clay pipe were limited in size up to about probably 150, 200 millimeters in diameter. They were very short, little joints every couple of feet in length. And as you know very well, wherever you have a pipe joint, you're probably going to have a leak. So that had some way to go. And then we had the invention of cement, or cement as we know it today. This was invented in 1827. It wasn't particularly good, it wasn't particularly reliable, but before that you had what was so-called Roman cements, whereas they were pozzolanic cements, made from naturally occurring materials, which came from a Mediterranean town called Pozzolana, pozzolanic cement. In the 1827s, they learned how to blend the right minerals and fire them and then grind them back to make cement as we know it today. It hasn't changed enormously since that time. But one of the great things was that in the major era of sewer construction in the 1850s and 60s, somebody began to do quality control. That meant that they could weed out the very poorly fired cements from the equipment. And a major step forward there. So in the 1850s, we began to see cement pipes being made, and in this great stink era, when a major £4 million was spent to construct about 95 miles of major interceptor sewer, 1,000 miles of feeder sewer. The £4 million then was probably about £300 million today, so quite a big expense, mostly, and invested all in about 10 years to construct this network. After that, people began to get more confident of putting steel into cement products, so they made steel reinforced pipe. The earliest pipes were probably in the 1850s. There's a pipe being dug out of a trench in New Jersey, which is supposed to have been made in 1847. Nobody really knows. Like many things in that kind of antiquity, the legend is probably better than the truth of it. And we had pipes being made from cast iron, then spun iron pipes, and then ductile iron pipes in the early 20th century. Asbestos cement was made in the 1930s, which doesn't seem to be such a good idea today, does it? And we had plastic pipes invented in the 1950s and 60s. PVC and GRP pipes, all of which have problems, all of which continue to have problems, and you have to deal with some of those problems now. Probably AC is a big problem, I guess. So that's a little bit of that background. Pipe there on the top left-hand side, that is the Cloaca Macro in Rome, which is still functioning. It's a stone-lined culvert, man entry size, runs right under the city of Rome, delivers sewage into the River Tiber. On the bottom there is an early clay pipe from about the early 18th century. And on the right-hand side of the picture, you've got a number of clay sewers. All of these shapes were built into the sewer system in Manchester. Now, what we see there is actually what we see in